Hello students, and welcome back to another algebra video. You know what to do. Pause the video and try this problem in your notes, and then unpause it to do it with me. Okay, find the value of x so that the function has the given value. So, we are told that f of x equals 6x plus 9, and f of x equals 21. Because f of x is equal to both of these things, they must be equal themselves. And now, we just have to solve for x. So, minus 9 on both sides. That leaves us 6x equals 12. 21 minus 9, yeah, 12. Divide by 6 on both sides, and we get 12 divided by 6 is 2. So what this means is when x is 2, then the output is 21. So when x is 2, f of x is 21, or we can say f of 22, or excuse me, f of 2 equals 21. Okay, that was a nice little review from yesterday. So now let's go ahead and see what we have for today. Today we're going to finish our work with section 3.3. We're going to tie it all together, everything we've learned so far in section 3.3. So our learning target is I understand the connections between how function notation works and how it is used. We're bringing it all together, so we're going to look how things work together, how things are connected today. The success criteria is that you can use function notation to evaluate, solve, and graph functions. So these pieces were actually in our success criteria. We evaluated in the first part of 3.3, we solved and graphed in the second part of 3.3, and now we're going to use all of those things in solving real-world problems using function notation. So, again, we're going to review what is function notation. Remember, function notation, it's like y equals, but instead we say f of x equals. And it is the value of f at x. So if x were 1, then f of x would be 7 in this example. Okay, so that's what function notation is. Now, we're going to tie it all together. We're going to do this problem on this screen. We're going to do a word problem on another screen. It's going to be fun. So, what does f of 2 mean? And how can we put it on a graph? So, as we go through each part of this, I want you to pause the video and try this on your own. Write your answers to these questions in your notebook. What does f of 2 mean? Can you tell me, if you see f of 2, what does that mean? Say it in your own words. And then, how can we put f of 2 on a graph? So, try that on your own in your notes, and then unpause it, and let's do it together. So, what does f of 2 mean? F of 2 means when we plug 2 in for x, when we take 2 as our input, what is the output? So f of 2 is the output when x equals 2. And the way that we find it is by taking f of 2 equals 2 times 2 plus 7. That's 4 plus 7, which is 11. So how can we put that on a graph? Well, remember that 2 is our input, or our x, and f of x is our output. or our y value. So that gives us the point 2, 11. And we're going to be slightly off of the graph since this is 10 right up here at the top. But that is how we would put f of 2 on a graph. F of 2 equals 11 on a graph. But we don't write it that way. We write it as 2, 11. And we understand that 2 is the input and 11 is f of x when we have the input of 2. Okay, what about f of -1? Why do we make tables? So again, pause the video and write your answers to these questions in your notes. And if you're like, I don't know, look back at your notes from yesterday. Pause the video, look back at your notes from yesterday, see if you can say, what does f of -1 mean? What is it, and why do we make tables? Try that in your notes. Okay, so f of -1, we can see f of -1 is 2 times -1 plus 7. -2 plus 7 is 5. So that gives us the point -1, 5. And you can already see that we can connect the dots. We can connect these dots and get a line already because 2 points make a line. Okay, all right. Why do we make tables? Remember in the problem yesterday where we were graphing, we made a table of x and y. We made a table of inputs and outputs. Now remember, when we're using function notation, the outputs are f of x. If you want to keep y on your table, doesn't really matter. But when we're using function notation, technically we say f of x instead of y. So, in our table, we would have 2 and 11, -1 and 5. We would have our inputs on this side, and when we plugged those inputs in, we would put the output right next to it. Why did we make these tables? Was it for fun? Did it help us accomplish the problem in any way? Yes, it does. Because as we choose more inputs, we can put more points on our graph. Input goes to output, and together we can use these to make an ordered pair. And the more ordered pairs we have, the more points we have on our line. Okay. So that's why we make tables. Now, let me erase this a little bit. And the next set of questions is, when will f of x equal 9? There are 2 ways you can find out. So I want you to pause the video. You know one of the ways. Like, I've shown you one of the ways that you can find out when f of x equals 9. I want you to pause the video. Can you think of the second one? I'm going to give you a hint. It's on the screen right now. Okay, pause the video and try this question in your notes. Okay, so the first way we can find out is exactly what we did in the entry task. We can say f of x, or 2x plus 7, equals 9. And we can solve for x. So that's the first way that we can find out. The second way is by looking at the graph. F of x is the output, which means it's like the y, right? So when is the y value 9? Well, right here, this is the point where the y value is 9. What is the x-coordinate of that point? 1. So if I solve this equation for x, I should get 1. And there's two different ways you can do, or you can figure out when f of x will equal 9. You can look at the equation and solve this equation, or you can look at the graph and find the x-coordinate when y, or f of x, is 9. Okay. So let's solve this and make sure that we get the same thing. We subtract 7 from both sides so that the 7 goes away. We have 2x equals 9 minus 7 is 2. I divide by 2 on both sides, and I get x equals 1. Oh, hey, that's what we had up there. So f of x will equal 9 when x is 1, or f of 1 is equal to 9. Okay, so that kind of brings everything together that we've done. We have evaluated functions, we have solved functions, we have graphed functions. The only thing that's left to do that we did in part 1 of 3.3 is to interpret functions. So we are going to move on to example 5 of 3.3. And this is a word problem. And word problems always require us to interpret something. So let's read the problem. It says, the graph, this graph, shows the number of miles a helicopter is from its destination. So how far away the helicopter is from its destination after X hours on its first flight. Okay, so we're doing two different flights. A helicopter is flying to a destination one time, and it's flying to the destination again a second time. Okay? On its second flight, the helicopter travels 50 miles farther. Oh, okay, so it's not the exact same trip. We're taking two different trips. One, we're flying to a certain destination. The second flight, we're traveling to a destination that is 50 miles further, and increases its speed by 25 miles per hour. Okay, so we're going 25 miles an hour faster than we were on the first flight. Okay, the function f of x equals 350 minus 125x represents the second flight. So we have the first flight here, and we have the second flight within this equation. And in this function that represents the second flight, f of x is the number of miles the helicopter is from its destination after x hours. Okay, just like the first flight. Which flight takes less time? Explain. Okay, so we have one flight is this table. The other flight is this equation. And we want to know which flight takes less time. Because on the one hand, we have our first flight, and we can see, well, how long did our first flight take us? Let's zoom in on this graph here. So, what does this graph mean? We need to figure out what this graph means. So, notice that I have a point 0, 300. I also have the point 1, 200, 2, 100, and 3, 0. What do these points mean? What do they mean? Okay, so the input is x hours. So number of hours. We can see on the x-axis we're talking about hours. How many hours has the helicopter been in the air? Okay. And what was f of x? The number of miles a helicopter is from its destination. So how much farther do we have to go? So at 0 hours, when we have been flying for 0 hours, we are 300 miles away from our destination. So, okay, let's write that down. When we start flying, we are 300 miles from our destination. When we start flying, we're 300 miles from our destination. We know that because of the point 0, 300. Okay, so our journey is 300 miles. So how long does the flight take? After 1 hour, we have 200 miles left to go. So that means, oh, okay, we're traveling 100 miles an hour because each hour I go 0 and then 1 and then 2. Each hour I have 300 miles left to go, 200 miles left to go, 100 miles left to go. So we are going 100 miles each hour. Okay, interesting. How long does it take us to complete the flight, right? Because the question is which flight takes less time. But how long does this flight take us? Well, let's see. At 3 hours, we have 0 miles left to go. So the point 30 tells us that the first flight, let me zoom out again. The first flight takes 3 hours. First flight takes 3 hours because after 3 hours, right, x is the number of hours, so after 3 hours, I have 0 more miles left to go. And if I have 0 more miles left to go, it means I don't have anywhere else to go. I'm there. I have arrived. I am at my destination. So that point tells us the first flight took 3 hours. Okay. How long does the second flight take? Because we want to know which one is shorter, which one takes less time. Well, for the second flight, I don't have a graph to look at. I have an equation. I have f of x equals 350 minus 125x. And this is for the second flight. So, how could I figure out how long the flight takes? I want to know how many hours it takes to get to 0, right? To get 0 miles away from my destination. So, what is x when we are 0 miles away? So, what is x when f of x equals 0? When the distance between the helicopter and my destination is 0, how many hours have I been flying? What is x? So I want to know what is x when f of x equals 0. Oh, so we just need to make f of x 0. and then I can solve for x. Okay, so let's zoom out again. So we're going to take 0 equals 350 minus 125x. Okay, let's solve for x. I'm going to subtract 350 from both sides. So we get negative 350 equals negative 125x. How do I get x by itself? Oh, okay, I'm going to divide by negative 125 on both sides because I have negative 125 times x. Those will go away. And what is negative 350 divided by negative 125 is 2.8 equals x. Okay, and why did we care what x was? Why were we doing this? Why does it matter that x is equal to 2.8? What does that mean? Well, what was x? X is the number of hours we've been flying for. X is how long the flight takes. And hey, so for the second flight, we know the second flight takes 2.8 hours. Second flight takes 2.8 hours. So, which one is faster? Which flight takes less time? Well, the first flight takes 3 hours. The second flight takes 2.8 hours. Which one takes less time? The second flight. The second flight takes less time. Ta-da! Okay, that took a lot of thinking, and it took a lot of interpreting, right? We had to figure out, what do the points on this graph mean? What does x mean? What does f of x mean? We needed to figure out that we wanted f of x equal to 0, and that would tell us how long it took for our helicopter to be at its destination. There were a lot of pieces we had to connect here. But if you followed with this problem and you're confident that you could do one like it, you know that you truly understand how function notation works and how it can be used in an application context. So let's check and make sure that we were correct. Whoops. Example. This should say example 5 solution. And let's see. Oh, they graphed. They actually graphed. But in the end, they did exactly what we did. Second flight takes 2.8 hours, which is less than 3. So, woohoo! We were correct. And, yay! We truly understand function notation now. So, at this part of the video, I would like you to reflect on what you have learned in this video. And just like usual, if you can rate yourself on a scale of 1 to 3, where 1 is, ooh, this felt bad. I had no idea what was going on in this video. And 2 is, kinda. I think kinda get it. And 3 is, woohoo! I am so ready to go do my homework. I understand. And remember, if you're a 1, that's okay. I was a 1 through most of college. So, if you're a 1, that is okay. If you're a 2, doing the homework should help you solidify your understanding. And if you are a 3, then maybe reach out to your friends, see how they're doing with their homework. Okay. Alrighty. Here are some practice problems that you can do to practice what you learned in this video. But of course, remember to do the homework that your teacher assigns as well. Oh, and more practice problems. They wouldn't all fit on one slide. Okay. All right, and as usual, let's end our video with a launch. This launch comes from Rosa Parks, and she says, each person must live their life as a model for others. As a model for others. Do you have a role model? Do you know what a role model is? So a role model is someone that you want to be like when you grow up. And not just like, so when I was in 6th grade, my role model was Taylor Swift. When I was in 4th grade, my role model was Hannah Montana because I wanted to be a singer like them. Now, role model means a little bit more than maybe when I was in 6th or 4th grade. A role model means someone that you want to be like in every way. So you don't just want to be like them because they're a singer, but maybe your mom is a role model for you because she's patient and she's kind and she's super caring in the way that she makes meals and provides for everybody in your household. Maybe your grandparents are role models because their relationship is so strong and has lasted for so long. Who is it that you want to be like? Can you think of that person where you think, oh man, I want to be just like that person? Now, what Rosa Parks is saying is each person must live their life as a model for others. So what she's saying is you should live your life so that you can be a role model for others, right? You wouldn't have a role model that like beats people up. Your role model wouldn't beat people up because that's not nice. You don't just beat people up for no reason. You want a role model, and your role model probably is kind and caring and thoughtful of other people. You want to live as a role model. So you want other people to look at you and go, wow, I want to be like that person. I want to be kind. I want to see the positives in life. I want to be happy. I want to help other people. You want to live your life so that other people see you and they go, wow, I want to be like him. Wow, I want to be like her. So, live your life as a model for others. Live your life in a way that other people want to emulate, not in a way where people are going to go, oh, ugh, we need fewer people like you in the world. No, we want more people like you in the world. So, live your life as a model for others. That is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.